Well, thanks so much, everyone, for joining. And I especially want to thank all of my co-authors who have led to the improvement and all of the ideas that I'm presenting here. And we wanted to take a little bit of time to talk about data quality in the context of adaptive management and adaptive monitoring, because as David highlighted, we're in this really exciting rangeland data revolution where the complexity of data that's available to us over broad spatial temporal scales and in the context of some really new and exciting collaboration frameworks is bigger and broader than it ever has been before. And while that brings a number of opportunities and exciting applications for rangeland management, it also does bring some concerns about how do we ensure data quality in this ever complex data world. And quality assurance and quality control, and talking about that, can give us some language and some tools to help ensure data quality throughout rangeland management. So I first want to talk a little bit about what do we mean by quality assurance versus quality control, because that's not always clear. So quality assurance is an anticipatory process to prevent errors from being inserted into your data, whereas quality control is reactive, where you're just trying to detect what's happened and, if possible, fix those errors. And we can think about data quality kind of in a new model of this is always happening when we are working with data. If you're thinking about collecting data or have data in hand, you have an opportunity to screw it up. And similarly, you have an opportunity not to screw it up. And so we can always be preventing errors throughout the data lifecycle. And then there are certain key points in the data lifecycle where we can work to detect and correct errors. We also recognize that in this new and complex data world, that data quality is going to differ depending on your role in the team and role in the collaboration, where what you need to do as a data collector to ensure data quality might be different than what the data manager or analyst does. Similarly, the steps we take for data quality are going to differ based on the kind of data you're working with, whether it's observational data or field-based observations, or maybe working with UAVs or satellite information. And finally, and actually really importantly, data quality varies over time, and that just as we have these longitudinal data sets that have measurements and changes in measurements over time, with those measurements and new people collaborating with those data sets, the level of data quality in the data set might vary. And rather than viewing that as a scary thing, I think we can view that as a really important learning opportunity to look at the past and look at what's happened, both the good and the bad in the past, and then think about moving forward and have discussions as a team to learn about what we can do. And so here we're arguing that Q is for questions, and that a really question-driven approach to data quality can help teams, research groups, collaborations, really start to think about the different components of data that they have and how they can improve it. And so for quality assurance, our questions are really around like what could go wrong, versus quality control is like what did go wrong? How could we detect what happened? And so our 10 questions are broken up into 4 main categories, and then there's one that's just super important and on its own. And the first set of questions are looking at defining what your data ecosystem is. What kinds of data are you working with? How might they be transformed over time as you work with them? What's your plan to prevent errors as that happens? And who's going to be responsible for what in that whole process? The next set of questions is going to be dealing with data management. How will those data be collected and stored? And what implications might that have on detecting or inserting errors into the process? And then the next set of questions are related to how will you prevent errors and how are you going to plan to prevent those errors from occurring? And that can be everything from like how will training occur, who needs to be trained and when, what is the calibration plan, at what interval do sensors or observers need to be calibrated, what's our calibration standard, what level of uncertainty are we comfortable with? And so after you've gone through all this planning work, the QC questions really start to jump in, and you start asking questions that get at how can we describe the errors or variability in our data set. And so the next question is, are the data complete, correct, and consistent? What are the sources of variability, and is there anything we can do to control those sources? And as we've discussed all of these questions and you maybe go out and collect data or work with data, it brings us to our last and most important question, which is the learning question of how can we do better next time? What has happened, good, bad, or indifferent, and how can we use that to improve data collection in the next season or working with data in our next research study? And all of that is really critical to this adaptive monitoring process that's central to adaptive management, where we're always learning from the past and learning how we can do better from each other and with each other in a collaborative setting.